In today's video, I am going to explain crystal defects or crystal imperfection. Now, what is crystal defects or imperfection? Which means crystalline substances do not have perfect crystal structure, which means they have some irregularities or some disorder in the arrangement of atoms in the crystal structure. Now, when defects are generated during the crystallization of solid substance. Now, whatever the nature of the crystal defects, the electrical neutrality of solid substance is maintained. Now, we will discuss first crystal defect, which is a point defect, and major class of point defect is stoichiometric point defect. Now, we have four types of stoichiometric point defect. Number one, vacancy defect. Second, interstitial defect. Third one, Schottky defect, and last one is a Frankel defect. Now we have the first stoichiometric point defect, which is a vacancy defect, and vacancy defect is going to be very important. Now, what is meant by vacancy defect? Vacancy defect means during crystallization of substances, the particles such as atoms or molecules are missing or they are absent from their regular site in the crystal structure. Now, because of these missing particles, the vacancy is created or vacant sites are created in the crystal structure of the substance. That you call it a vacancy defect. Now look at the vacancy defect. This is vacancy defect, and you can see over here some particles are missing from their regular site in the crystal structure. Now, because of these missing particles, the vacancy is created or vacant sites are created in the crystal structure of the substance. Now, because of this missing particle, the mass of the substance decreases, but the volume remains unchanged. Therefore, the density of that substance decreases. So, mass decreases, volume remains unchanged. Therefore, the density of that substance goes on decreasing. So, that was regarding the vacancy defect. So, that was regarding the first stoichiometric point defect, vacancy defect. Now, we will discuss second type of stoichiometric point defect, which is interstitial defect. Now look at the interstitial defect. This is interstitial defect, and you can see over here some particles of crystalline solid occupies interstitial sites in the crystal structure. This is called interstitial defect. Now these extra particles increases the total mass of the substance without changing in the volume. So that is why the density of that substance increases. We can explain interstitial defect in the second way also. Now look at the interstitial defect in the second way. You can see over here the particles leaves its regular site and moves to occupy interstitial place, which means they get shifted from their original place and moves to occupy interstitial place. Here there is neither gain nor loss of mass of the substance. Therefore, the density of that substance remains same. In the first way of interstitial defect, there are extra particles, therefore the mass of the substance increases, therefore the density increases. But here the particles only leaves its regular site and moves to occupy interstitial place, means there is neither gain nor loss of mass, therefore the density of that substance remains constant, remains same. Now we have third stoichiometric point defect, which is a Schottky defect, and Schottky defect is shown by ionic compounds such as sodium chloride, potassium chloride, or silver bromide. Means one is positive ion and other is negative ion. Now this is, I have taken one ionic compound in which one is negative ion, other is positive ion. Negative ion is an anion, positive is a cation, and anions are bigger in size while cations are smaller in size. So you can see that one anion is missing from their regular site in the crystal structure, and one cation is missing from their regular site in the crystal structure. Means these missing particles, now because of this missing particle, the vacancy is created or vacant sites are created in the crystal structure of the substance. Now this vacancy is due to missing of one positive ion, also one negative ion, which means equal number of positive and negative ions are missing to maintain the electrical neutrality of that substance. Now because of this missing particle, the mass of the substance decreases. However, the volume remains unchanged. That is why the density of such substance decreases. So mass decreases, therefore density decreases. So this effect which arises due to the vacancy caused by absence of one cation and one anion, that is called Schottky defect. So that was regarding the Schottky defect. Now we have the last stoichiometric point defect, which is a Frankel defect, and Frankel defect is also shown by the ionic compound. For example, silver chloride, silver bromide, silver iodide, means one is positive ion and other is a negative ion. Now I have taken one ionic compound, and this ionic compound shows the Frankel defect. One is a cation and other is a anion. Now you can see from this figure, one particle, one ion, means one cation, is missing from their regular site in the crystal structure. But this missing particle, this cation, occupies interstitial space in the crystal structure. Because cations are smaller in size, it is easier for them to accommodate interstitial space. Means here total number of particles in the crystal structure remains same. That is why the mass of that substance remains same, and because the mass of that substance remains same, the density of such substance remains unchanged, remains constant, or remains same. So this is how we consider the Frankel defect.